So a little bit more about logarithms we need to know. First, just wanted to illustrate a little bit about what we talked about in the first video, which is that logarithms and exponentials are inverses of each other. If you remember inverse functions, they are reflections of each other over the line y equals x, which is represented by the dotted line in this picture. So you see in red what y equals 2 raised to the x looks like. That's an exponential. You see in blue what log base 2 of x looks like, and that's a logarithm. So they are inverses of each other. They do opposite things. So next thing we need to know how to do is talk about their transformations or translations. We talked about this with exponentials earlier, so now we're going to look at it with logs. And if you remember how it worked with exponentials, you'll see that it's a very similar pattern here with the logs. So in the first one, log of x plus c. Now that plus c is not inside the log. If you look down a couple, you can see you have to put parentheses to make that true. So that plus c is actually applying to everything, the entire log. That means it's affecting the y value. Whenever you're affecting the whole function, you're affecting the y value. And if you're affecting the y value, that means it's a vertical issue because the y-axis is vertical. So plus c would move you up c units. And minus c is going to move you down c units. So if you look at the next two, log of x plus c and log of x minus c, here the c's are only affecting the x, and x is horizontal. X is left and right. So x plus c, like before, it probably seems backwards, is going to be left c units, and minus c will be right c units. So hopefully you're seeing the pattern and the similarity with what we had with the exponentials. If you add or subtract to the whole thing, it's vertical. If you add or subtract from just the x, it's horizontal, left and right. Now the last two are reflections, and they're also very similar to what we did with exponential. The first one is applying the negative to the entire function. And if you're doing something to the entire function, you're affecting the y value. So that means you're going to be doing things vertically. So this would be a reflection vertically. You could also say it reflects across the x-axis. Okay, so a vertical reflection is also a reflection across the x-axis. Now in this last one, it's log of negative x, so it's only applying to the x, which means it's only a horizontal movement, so this would be reflecting it horizontally. Or you could also say it is reflecting it across the y-axis. So the negative log of x is an up-down flip, and the log of negative x is a left-right flip. So let's look at a couple examples and just describe what they would do. Log of x minus 1 plus 2. Well, we've got two things happening. The x minus 1 is a left and right movement because it's only applying to the x. So this would move it right 1 unit. Now plus 2 is going to move it up 2 units. Up 2 units. So right 1, up 2. When it's just applying to the x, it's left and right. When it's the whole thing, like the plus 2, that's moving it up and down. Okay, in this next example, we also have two things. We have the negative here and the plus 3 here. The negative out front is applying to everything, so that means it's going to be a vertical reflection. Because when it applies to everything, it's going to be a vertical movement or reflection. So vertical reflection. And then the x plus 3, that's a horizontal shift because it applies only to the x, and plus 3 is going to make it move left 3. Then our last example with this is we have a negative here and a minus here. The negative that's only applying to the x means it's only going to be a horizontal movement because it's only applying to the x. So that would be a horizontal reflection. And the minus 4 is applied to everything, so it's going to be a vertical movement, so it's going to move down 4 units. Okay, let's move on and talk about the domain of a logarithm. Now, you can only take the log of positive numbers. I'm just going to pull the calculator up and kind of show you that. If you do the log of 7, no problem. If you try to do the log of negative 7, you get an error, non-real answer. You can't log a negative number. Okay, you also cannot log 0. That's also going to give you an error. So you can only log positive numbers. So I said that very specifically. You can only log positive numbers. That means you can't log 0, and you can't log negatives. Okay, so when you're asked to find the domain of a logarithm, remember the domain is the set of all x values that can exist in the function. All you have to do is take what's inside the parentheses and set it greater than 0. Just greater than, because we can't be equal to 0. You cannot log 0. And that's true for any base. It can be common log, natural log base 4, log base 11. Any log, this is true. So all we do to find it is we say, okay, I have to log only positive numbers. So x plus 3 has to be greater than 0. Then just subtract the 3 from both sides, and you get x is greater than negative 3. And that would be your domain. Another way to write that, since we're doing x greater than 3, is it would be from negative 3 to positive infinity. That would be another way you could write the same thing. Okay, so keep in mind, this is an important distinction. It doesn't mean that you can't plug in negative numbers. It means that your result when you plug the number in can't be negative. So if you look at this, this says x is greater than negative 3. So if I plug in negative 2 here, that's fine, because negative 2 plus 3 is positive 1, and I can log a positive 1. So it's not that you can't necessarily plug in negative numbers, it's just that your result can't be negative inside the parentheses. So here we have log, this is the common log, but like I said, it makes no difference, of x plus 5 minus 2. Now I only care what's about inside the parentheses. So I only care, that's the only thing that will affect my domain. So I have to make sure what's inside the parentheses is positive, because I can only log positive numbers. Okay, so I do x plus 5 has to be greater than 0. I subtract 5 from both sides and get x has to be greater than negative 5. Okay, for my third example here, we have the natural log. Again, doesn't matter what kind of log it is, we can only log positive numbers. So 3 minus x has to be greater than 0. Now for this one, I'll subtract 3 from both sides, but then I've got to divide both sides by negative 1, which means I have to flip the inequality sign. So I get x is less than positive 3. Okay, now this last one's a little bit tricky. Has x minus 3 squared. So let's write just what we normally have been. We take the parentheses and we say it has to be greater than 0. Okay, x minus 3 squared is greater than 0. Now you may be tempted to square root the answer right here and then add 3 to both sides and say you're finished. But you need to stop and consider this for a second. X minus 3 squared greater than 0. Well, whenever you square a number, it's going to be positive, right? So that means you should be able to plug in anything for x, except for one thing. There's one thing that we could plug in for x that would not make this greater than 0. And that would be 3. So this one turns out to be x does not equal 3. So in this one you just have to keep your eyes wide open and remember, okay, if I square things, they always become positive except 0. 0 squared is just 0. And so I can't be 0, so that means x can't equal 3. But anything else I plug in for x is going to result in a positive number, so anything else will be fine. So in this case, we would have all real numbers except for x equals 3.